Lecture 10.3, Day 1, Polar Coordinates. One way to give someone directions is to tell them to go 3 blocks east and 5 blocks south. Another way to give directions is to point and say, go a half mile in that direction. Polar graphing is like the second method of giving directions. Each point is determined by a distance and an angle. A polar coordinate pair r theta determines the location of a point. The angle is measured counterclockwise from the initial ray, which would be horizontal on the x-axis, and r is the radius, which is the distance from the origin. Some curves are easier to describe with polar coordinates. For example, r equals a describes a circle centered at the origin. Theta equals theta sub 0 is a line through the origin. And this, r is between 1 and 2, and theta is between 0 and pi over 2, gives this shape. More than one coordinate pair can refer to the same point. This illustrates 2 30 degrees, but it could also be -2 210 degrees. This might be a good time to mention that an unfortunate aspect of polar coordinates is that the distance is given first, and then the angle. But if you're actually going to draw the point, you need the angle first, and then the distance. This point could also be -2 -150 degrees. All of the polar coordinates of this point are 2 30 degrees plus n times 360 degrees, and -2 -150 degrees plus n times 360 degrees, where n is 0, plus or minus 1, plus or minus 2, etc. In other words, n is an integer. Tests for symmetry. X-axis symmetry occurs when, if r theta is on the graph, so is r negative theta, as in this graph of r equals 2 cosine theta. Y-axis symmetry occurs when, if r theta is on the graph, so is r pi minus theta, as in this graph of r equals 2 sine theta. Or negative r negative theta. Origin symmetry occurs when, if r theta is on the graph, so is negative r theta, as in this graph of r equals plus or minus radical tangent theta over cosine theta. Or r theta plus pi. If a graph has two symmetries, then it has all three. For example, r equals 2 cosine 2 theta. Let's graph this equation on the TI-89. R equals 2 cosine 2 theta. First, we change the mode to polar graphing by pressing Mode, Graph, select 3, which is polar graphing, and press Enter. Then we press diamond y equals and enter the equation r1 equals 2 cosine 2 theta and press Enter. Pressing diamond window, we set theta minimum as 0, theta maximum as 2 pi, choose an appropriate theta step, set x min to -4, x max to 4, x scale to 1, y min to -2, y max to 2, and y scale to 1. Then we press diamond graph to see our graph. This particular graph is referred to as a four-leafed rose, although it looks a little more like a daisy to me. Notice that it says in the lower right-hand corner of the screen on your calculator that you are in polar graphing mode. Don't forget, if you're done with polar graphing, to change your calculator back to function graphing.